Hi guys, this is Ms.Hong. Today is June 8th, Monday. Happy Monday. And today we have a final for seniors. So if you're a senior, then you need to go to Agilastic and you need to take the final. And also you need to do this classwork. Alright? So you have two things today. Your final and lesson, okay? But like today's lesson, like I'm not gonna deduct any points for the late submission. So if you cannot do it today, you can do it tomorrow, but you need to do the do now anyway, right? And yeah, that's it. And my sophomores and juniors, you have final on next week, next Tuesday and Wednesday, but that is not Agilastic test. That will be NWEA test. All right, so June 16 and 17, my sophomore and juniors, you have final. That is NWEA. You know what's NWEA, right? So we will have that one as final. So just like keep in mind, I'm gonna remind you anyway. All right, and by Friday last week, we talked about the exponential function, right? Exponential growth and decay function. And today, I'm gonna review exponent rules because you're supposed to know this one because you should learn this one in Algebra 1. But like I know most of you are not, so I'm gonna do this one for today. And next lesson, I'm gonna do two more properties. And the next lesson, I don't know if I would have time or not. We will use all the properties and we will do the translation. You remember transformations, right? Shifting right, left, up and down, and flipping, like something like that about exponential function. All right, so today let's go over these properties. So we have product rule, quotient, zero property, power rule, and expanded power rule. So we have these 5 rules. I'm gonna go over these 5 rules for today. And next lesson, I'm gonna give you 2 more properties, all right? And then we will move on to the transformation of the exponential function, all right? So guys, let's go. Number 1, look at number 1. I'm gonna make it bigger. So when you look at number 1, it says product rule, right? Because your product, you're doing multiplication for 2 powers, right? But the thing is, you know what? Your base, look at the base, it's x and x. So when your base is same and you're multiplying 2 same base, but they have different power, but they could be same, that doesn't matter. So anyway, when you're multiplying this 2, then you're adding the exponent, m plus n. Because let's see this one. What if I have like this, 2 squared times 2 cubed, right? Then you already know 2 squared, that is what? 2 times by 2, right? And then what's 2 cubed? That is 2 times by 2 times by 2, right? Then look guys, how many 2's do you have? 5 2's, right? Like this, because you multiply all these 2's, that's 5 of them, so we can write it like that. And this 5, that's same as what? 2 plus 3, right? So that's the product rule. When you have the same base and you're multiplying 2 things together, then we can add exponent, right? So look at this one guys. Do you see x and x here? X and x. So I got the same base, so I can combine this two, because that means I have 3x. This one as I have 8x, right? 3 and 8 together, that's 11. So you can just answer that x to the 11th power, right? And look at this one guys. 2 to the 4, 2 squared. Then what? Now you can just do, oh, I have the same base. So let's write it once and let's add it. 4 plus 2. So you get 2 to the 6th power, right? And C, that's complicated, right? That's complicated. But look, guys, you have this parentheses, but I'm gonna get rid of this parentheses, all right? So x squared, y, x cubed, y to the 4, right? Because it's all multiplication, so you don't have to distribute anything. But normally you distribute something when it's multiplication, and inside you have addition, like something like this. You have two different operations, then you should distribute the thing. But this case you have product, product, product. It's all product, right? So you can just get rid of the parentheses. So you do this, and we can combine only same base, right? So let me rearrange it, all right? So x squared, x cubed, y to the 4, like that. And then, I'm gonna combine this x together, x and x. So what, how many x in total? 2 and 5, 2 plus 5, 2 plus 3, so will be 5, right? And from y, guys, look, nothing. What does that mean? No power, that means 1, right? Nothing means 1, so it's 1 plus 4, also 5, right? So when you have like little complicated thing, then expand everything, get rid of your parentheses, and combine the same base together. So that's my solution. This is my solution. This is my solution. Okay? So when it is multiplication, then what? We add it, right? And look, my second rule, that is quotient rule. Quotient, that's division, right? So when you divide it, same base, division. Think about it. Product, then you add. Divide, then you subtract, right? When you have it, you subtract it, because look at this. I will show you this one. So x to the 5th power, then that is x, 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 x. You have 5x, right? And x squared, you have 2x. So you simplify this, right? Cancel, cancel. Then what? How many x do you have? You have x cubed, right? And this cube, that's same as what? 5 minus 2, right? That's same as 5 minus 2. So when you have division like that, then you can subtract the power. Okay? Then what about this one? 3 to the 5th, 3 cubed. Then 3 to the 5 minus 3, like this. So you get 3 squared. Okay? And see, guys, we are combining only same power, right? So let's think about x first. X and what? 2 minus, what do you see? Nothing, so that is 1. So 2 minus 1 times y, what? 5 minus 3, like this. Then you get x to the 1, so I'm not gonna write it, times y, 5 minus 3 squared. Okay, so this is the quotient rule. Alright, and let's move on to the third one. So guys, you already know something like you just have x, nothing, then that means 1 here, not 0, right? And y, you just have y, then what? That's 1, right? Nothing means 1, 1 power, and also your coefficient, nothing means 1, right? But look, when it is 0 power, then that's always 1. Whatever 0 power, that's 1. Alright, so 100 to the 0 power, 1. Negative 5 to the 0 power, like this, then that is 1. Okay, do you see I put the parentheses for that? When you have, if you don't have it, then will be negative 1 because of this negative sign. But anyway, anything to the 0 power, that's 1, right? So look, y to the 0 power, 1. 6 to the 0 power, 1. Look at this craziness in the parentheses. You have a lot, right? But anyway, what? Something to the 0 power. So cover this part, cover it. When you cover that, then you just have 0 power, so it is 1. Alright? So that's the 0 exponent rule. And our fourth rule, that is power rule. So to use it, you have an exponent, right? Like this, you have an exponent, but there's another exponent with parentheses. Then in that case, what do? We just multiply this 2. Because think about it, guys. Let me use this one. So just look at the outside first, like this. Just cover the inside and just look at the outside, guys. How can I cover everything like this? So don't look at the inside. Then something squared, right? Something squared. Then you know what? We need to write the inside twice because that's squared, right? Then I can do this, right? Because you know x squared, then what do? That's x times by x. So x cubed squared, so you multiply x cubed twice, right? Like that. Then that is x, and this one is x, right? How many x? 6, right? So that's same as x to the 6, right? So look, 3 times by 2, then you get 6. So look, x cubed times x cubed times x squared, like this multiplication, then that is x to the 5. But x cubed squared, right? You have only one base, power to the power. Then you multiply it, that's x to the 6th power. Okay? Then what about this one, guys? 3 squared to the 4th power. Power to the power. Then we multiply the power. So 3 to the 2 times by 4 will be 8. Right? And what about C? Same thing, power to the power. So z to the 5 times by 2, which is 10. Alright? So power to the power. And also, you know what, guys? Because, like, you know, mn, that's same as x to the n times by m. I can switch the order because we can use commutative for the product, right? And then I can just rewrite it x to the n to the m, right? So you can switch this power. So outside power, you put it inside, and inside you put it outside. That's fine. You can switch this too. Alright? We will use that property a lot. So this is important. Because 1, 2, 3, the property 1, 2, 3 is kind of basic of the basic. So this is like something algebra 2 stuff. Alright? So power to the power. Just keep in mind that. And expanded power. So this is like distributing. So you can easily think about when you have one power but you have two different base, right? Then you can distribute this power from here, from there. So you just write it x to the m, y to the n. Alright? So look at this. Then what? This one you distribute because you have two different base, right? Then 2 cubed times a cubed, like this. And for b, then what? Look at this. That's 6 times x cubed, right? So you can do 6 squared times x cubed square. And then this is 6 squared times x to the power 6, right? Guys, I have 2 more problems, but I have only like 40 seconds left. So I'm gonna record these 2 examples on the second video. So see you later.